Hi learners, welcome to our lesson today. I'm glad having you here. Today we'll be looking at the periodic table, and with me here on the board I have already drawn a blank grid resembling the periodic table. You can see it containing several rows and columns. Also some parts are protruding like this one over here, and also two more boxes here. On this other side I have the first 20 elements written in their chemical symbols, number 1 up to number 20. That is what we'll be mapping on this grid. Also, I have some box here which is a bit larger than others. Okay, we'll discuss that. But before we start mapping them on the grid, we can start by, I can show you the comprehensive periodic table. It is over here, and here it is. This is the comprehensive periodic table. And just by having a glance at it, we can notice that it has a lot of columns, a lot of rows, but then it also have different colors. I believe it's not for decoration. Okay, I have a color here, a different one here. There are two columns but with different colors. I have also another one here painted yellow all through. I have one that is separated down here. I have some green colors here, which some are dark, others are light green. I have another color here, I think blue. Yes, it is made up of different colors, and this is because the elements, when grouped together or when written in order of their increasing atomic number, like this one is number 1, number 2, number 3, number 4, they keep on increasing. With the increasing atomic number, they end up grouping themselves and they form columns in which, if elements belong to one column or a certain column, they will end up having the same physical and chemical properties, and if not the same, related chemical and physical properties. So something else is that some columns up here are at higher levels than this one. So this gap that you can see here, I mean the yellow part here, we don't study about it. So I mean about when you are in high school level, yes, I'm doing here, we don't study these elements here. There are so many, and then they usually have diverse properties. They have diverse properties, like copper might have a diverse property, or might be too different with titanium, or maybe with another element like, yes, this is titanium. We have scandium, they might be so different, so we leave it at that. And this whole column here is the one that I've said here, a big block that we are leaving out. But then, since it is a periodic table, we are showing that something has been left out here, and this is what we will not be studying. And to start with, this part here, the yellow part, you can see from the key, it is the transition metals. They are called the transition metals. So anytime you are asked what is the name of the elements which are contained here, you just say they are called the transition metals, or transition elements. Okay, and they are metals. All these are metals, but they are left out. You can see examples. We have a metal like iron, a very common metal. We have another metal like copper. We have zinc over there. We have aurum. We have gold here. We have cadmium, and also these ones here. They are not metals now, but you can see they have been removed from a box here. Okay, let us leave that alone. Let us leave that. But then we can say that these are transitional metals. Transition metals. And then you can just shoot this part. We will not be mapping any of our elements on this part because those are not, none of these is a transitional metal. We won't be mapping any of them here, so I just shade it to avoid confusion. That is shaded, but you know what it contains. So from there, we also have other different colors. Like here, we have a different color with here. These are metals also. These ones here, some we see that they are poor metals, and also we have non-metals, we have noble gases and halogens over here. We'll be seeing that after mapping our elements on our table. So let us go back to business. We said we have our first 20 elements from hydrogen to calcium. I've written them in their chemical symbols, and previously we saw that chemical symbols must start with capital letters, and if they have a second letter, then it should be a small letter. a capital letter and a small letter. Okay, then let us map them. This is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. That is it. And it's stressed on the need of knowing those elements by heart from number 1 up to 20. That is not too much because we have over 100 elements. If we were to know all of them, then it could be a huge problem. But we have just no 20 of them. Let us map them. I'll be starting with the first element, which is hydrogen. We said that the periodic table contains these elements arranged in order of their increasing atomic number. So we will be going with the order of increasing atomic number. So from hydrogen all the way to calcium. And then we will be going from a left side to a right side. From here to that other box, then back here and all through to that side until this will be the end of our periodic table. So I'll be starting and saying this is hydrogen. But let us first write the numbers from number 1 up to number 20 and then write our elements. So this is number 1, 2, 3, 4, just a small number to leave space for writing the element, 9, 10. (18, 19, 20). So you should note that no number was written here in the space for transitional metals. No number was written. I'm stressing it because sometimes you will just be given in the exams, you are given a periodic table and then they leave a gap here, and if you mistake it and then include elements in this gap, then you'll mess up because it will end up not getting to this other point. It has a specified number of rows. It has up to 8 rows. When you include this, it becomes 9. I mean the columns. It is 8. So if I include some elements here, I'll miss out on this side. Okay. And now since I've written the numbers for number 1 up to 20, let us now map our chemical elements using their symbols on the map, on the grid. I'll be starting with hydrogen again. Hydrogen. Yes, that is hydrogen. Let us go to the next one. It will be helium. Helium on this side. Helium that way. Number 3 is lithium. From here, number 3 is lithium. We write it here. Lithium. Number 4 is beryllium. Number 5 is boron. Number 6 is carbon. Number 7 is nitrogen. Number 8 is oxygen. Number 9 is fluorine. 10 is neon. So just come here, I continue and then skip this part for transitional metals and then continue. Number 10 is neon. Number 11 is sodium. Come back with the red pen. You will see the reason why. Number 11 is sodium. Number 12 is magnesium. 13 is aluminium. 14 is silicon. 15 is phosphorus. Yes, phosphorus. 16 is sulfur. 17 chlorine. 18 argon. 19 is potassium from kalium. 20 is calcium. Yes, we have just mapped our chemical elements using their chemical symbols into a periodic table grid. We have seen on number 1 up to 20, we have shaded this part. So that was the main task for the day. Let us now continue to the other part, whereby we see the reason as to why it is called a periodic table, and then we can see why they are being written in this order and not in any other order. Okay, you cannot map them in any other way. This is the way. Since the scientists made their discoveries, they struggled so much. I mean, they struggled because it was a process. From different years, they were supposed to group them, and finally they came out with this. So from this now, let us see why it is called a periodic table. And the reason as why it is called a periodic table is because the elements are organized in periods. They're organized in periods, and periods are horizontal arrangements. I'll be writing it here. And see, let us see what periods are. Periods. Periods are horizontal arrangements. So, and when we talk of periods, we number periods using the number system. I mean 1, 2, 3, using that number system. So I can have this is the first period here. And when I talk of this, I mean the whole of this row. So hydrogen and helium are in period 1. Hydrogen and helium are in period 1. If I go to this other row here, lithium, beryllium, and all these are the elements preceding here. Okay, these are the elements coming after beryllium are all in are all in period 2. Period 3, so from sodium all the way to argon, that will be period 3. And we'll be having period 4. And it continues like that, period 5, 6, as you saw in a photograph the other for other periods, but up now I'll be running up to period 4. So let me write the let me continue here. So this is period 1, like that. This is what I meant by the number system. Period 2, period 3, period 4. So these are periods. And since it is arranged in periods, that is why we call this grid the periodic table. Yes, the periodic table. And then we have on this other side counting, that is counting the rows. The first row, second row, third row, and fourth row, and continually, those are the periods. But now we have another arrangement whereby we have groups arranged in columns. We have the first column, second column, third column. We won't be counting this in that because we saw, in fact, this one is not just one column. There were so many columns which were being represented. All this, there were so many columns, so we just leave it at that. In advanced levels, they will give them groups also, but we'll be learning from group 1 up to group 8. So I've just written the periods and I've said that columns now are referred to as groups. This is the first group, the second group, third, fourth, fifth, sixth, the seventh group, and the eighth group. Let us write that. And when it comes to group, we don't use this number system. We use the Roman numerals. Yes, we use the Roman numerals to indicate groups. So let us use them. We'll be having group 1. So I first write here groups, and then group 1, group 2, the Roman numerals. You'll be asked, in what group is beryllium? If I say it is in group 1, someone might be tempted to say that you are wrong. Since we don't say it is in group 1, we say it is in group 1. That is why we have to use these Roman numerals. Let us begin. Group 1, group 2, beryllium, sorry, this boron, group 3, group 4, group 5, 6, 7, and 8. I jogged my mind. That system, I used it a bit long ago. Okay, group 1 to group 8. Yes, I said this one is not counted. So if you maybe placed elements here, it might be wrong. So we have just seen what periods are from period 1 to period 4. We have seen what groups are from group 1 to group 8. And as I said, it's important to know this from number 1 up to number 20 so that you can know how to map them here. Now the next step, now before we go to naming these groups, and so we'll be looking at how you can just draw a simple periodic table. You know, some people maybe we learn differently, but we find some people first know how to draw the periodic table, and then they know the first 20 elements. Others know how to name the first 20 elements, then they can map them on the periodic table. But it is also very important to know how to draw this grid by yourself and then map your drawing the grid by yourself and then mapping the elements on that grid. So I'll draw a simple periodic table here very fast so that you can see how you can draw by yourself. Yes, and learn from it. So this was potassium and calcium. So I'll just we said we have different periods. Yes, we have different periods 1 up to 4. That is not it is very important, but in our drawing so that we can begin the elements going now downward is not such a much a big issue. The issue is naming the groups, because first, because of this the transition metals. Another reason that you can make errors, you have to know that we have hydrogen and helium, and both of them are protruding. They are in period 1 by themselves, hydrogen and helium. So when you come to the third element, it is lithium, and then the cycle continues. So let us draw a simple periodic table very fast, assuming you don't have this. Yeah, we don't have this. We want to draw ours just from our head. Yes, I know that in my head we usually have 8 groups, and we have the transitional metals coming after group 2. I'll be going to group 1, that of hydrogen, group 2, that of beryllium, and then in the third group I'll be leaving a space for transitional metals. Simple. And then without counting these transitional metals, I will be having 8 groups. Yes, I'll be having 8 groups without counting this. So I'll draw like this. So that is the group for hydrogen, and then hydrogen is around there. So like that, that is the second column. Yes, second column. From there, I can put a column which is a bit larger to differentiate it from the rest. This one is a bit larger as compared to this and this, because it is made up of transitional metals. Let me shade it this early so that I cannot count it. So I got 1 and 2. I have to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8 without counting this. So it is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And in the 8th group, I have another protrusion here whereby we have helium. So I said periods are not so much confusing, but the groups are confusing because you have to count it and have to eliminate this, but you also have to include it. Sometimes in the exams they don't include the transitional metals while drawing the grid. So it is up to you to count the number of columns, and if they are 8, you can know, okay, they have not included the transitional metals. But if they are 9, you will say they have included the transitional metals. So while you are mapping your elements, you will know that you either have to leave some space, or maybe you won't include that space. Okay, so I have drawn 8 columns. I've drawn 2 protrusions for hydrogen and helium. Good, hydrogen and helium. And then I know we have period 1, period 2, period 3, period 4. So how many columns? This is period 1 already. Let me add 3 more columns. 1, rows, 2, and the third one. So it gets up to here. So I can add up to there that way. And then it is also very important to know the elements from number 1 up to 20. Because if you miss the order and then you missed even drawing a periodic table, and sometimes they just tell you element X. You're talking of element X. They will be asking you question on element X. That means if you don't know how to map it, then you won't know even what X is. You can't write a chemical equation about X. Maybe you can't say the properties of X or how it reacts with other elements. So it is very important to know the elements from number 1 up to 20. Let us now map it. Map it again. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, number 13, number 14, silicon, phosphorus, 15, 16, sulfur, chlorine, argon. After argon, we have potassium, calcium. Yes, and it is done. As simple as that. Mapping our elements on a periodic table or on this grid. So having known it by yourself now, even it will be easier when you're given a periodic table in your maybe in your papers. You're given a periodic table and you are told to you are asked question about it. They just put some unknown letters. They ask you talk about this element. How does element X react with element K? Such mapping it by yourself is important. Okay, that's said and done. Let us now go to the other part. By now, I wrote these elements with different colors. Look here, I have a color red here and a color blue on this other side. And the reason as to why I did that is simply because on this side we have metals. On this side you have metals. These are metals. Starting from this, these are metals. These are metals. An exception of hydrogen. These are metals. These are also metals. Silicon is also a metal. Though some properties not exactly like those of metals, but it is called a metalloid. It shows properties of both metals and non-metals. Let us put it to be a metal. The same to boron shows both properties of metals and non-metals. So substances that show both properties of metals and non-metals, they can be considered as metals, but also they show properties of non-metals are called metalloids. Metalloids, so these are metalloids, silicon and boron, but we can consider them as metals. Yeah, for our study, let us consider them as metals because they show properties of metals too. So I've said these are metals, these ones are non-metals. And in this syllabus, there are some things that you'll be sure that you'll be studying. I mean, for this, some of these groups have their names. We have group 1, group 2, group 7 is over here, and also we have group 8. Those groups have names. And group 1 here, we have said it is metals. Group 1 is referred to as alkali metals. Alkali. Group 1. So I mean hydrogen, lithium, sodium, and potassium. And speaking about this, hydrogen is exempted. Okay, hydrogen is the most abundant element in the world. Hydrogen. Yes. And this hydrogen can be placed in either group 1 or in group 7. It can be placed in either group 1 and in group 7. Maybe as you study, you can see that hydrogen is atomic number 1. It has a configuration of 1. A configuration of 1. To gain stability, it can either lose 1 or gain 1 electron. It can lose 1 just like these other alkali, just like these alkali metals, or it can gain 1 like these elements here. This group 7 called halogens. That is why it can fit on either group 1 or in group 7. And because of its such properties, now it is exempted since it is not a metal, but the rest are metals. These are metals, and they are called alkali metals. Alkali metals. Alkali metals, group 1. Then we have group 2. This group 2 also have a name. We have beryllium, we have magnesium, we have calcium. Not sure what is down here, but let us just mention it. After calcium, we have strontium, we have barium, we have radium. Those metals, they are called alkaline earth metals. Group 2. Group 2, alkaline earth metals. Alkaline earth metals, group 2. Then we have group 3, no name, no specific name for them. Group 4, no specific name. Let us jump up to group 7. Yes, group 7. B1. Group 7 are called halogens. Halogens. group 7 are halogens. We have group 8, also referred to as group 0. Yes, group 8 or group 0. Group 8 or group 0. Because these elements are stable, they lose or gain nothing. Group 8 or group 0, they are called halogens. I've just written them here. We have fluorine, we have chlorine. Down there we have iodine, we have bromine, we have two more. I want to check on that. We have several halogens. So we have referred to these groups with names. From alkaline metals, alkaline earth metals, group 7 halogens, and then I was just talking about group 8. Group 8 V111. They are called noble gases or inert gases. Let's call them noble. This one, what I said is group 0. Yes, group 8 or 0. They are noble gases. Helium, neon, argon, krypton, xenon, radon. Yes, like that. Those ones, they are called noble gases because they are inert. Inert means that they don't react with other elements because they are stable. Okay. From there, we have seen groups. Let us mention something about their configuration. This is group 1, group 2, group 3, 4, 5, 6, 7, 8, like that. If we check on the configuration, I'll be writing the configuration of the very last element in each group. So we have potassium. Potassium has a configuration of 2, 2, 8, 8, 1. That one gives a total of 2 plus 8 is 10, plus 8 is 18, plus 1 is 19. It gives the atomic number 19, 2881. That of calcium is 2882, an addition of 1 electron. That of aluminium is 2883. Yeah, is that the case? No. 283 to get that in. Sorry for that. Silicon here is 284. So we moved from period 4 to 3. Phosphorus is 285. Silicon, sulfur. Chlorine 287. And argon 288. So these are the electronic configuration of each of the last elements in each period, in each group. So we can see, we want to see the relation, and let us use the same period in that case. Sodium is 281, magnesium is 282. So the first thing to note is that the elements in period 3, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, those are the period 3 elements. The elements in period 3, each and every one of them has an electronic configuration with 3 energy levels. Yes, with 3 energy levels. Each of them has 3 energy levels. 1, 2, 3. 1, 2, 3 up to argon. 1, 2, 3. And from there, we go to the next level. So to the next period. So we can say that a period, yes, shows the number of energy levels of an atom of an element. Yes, a period shows the number of energy levels of an atom of an element. So given a certain element X. Element X has a configuration of 286. And you are told, in what period does this element belong? You don't have to know what X is, but element X has a configuration of 286. in what period does it belong? It becomes automatic because the number of energy levels is the same as the period in which that element belongs. Since it has three energy levels, 1, 2, 3, it is simple. It belongs to the third period. We saw that for calcium, for potassium is 2881. It has 1, 2, 3, 4 energy levels, and therefore it is of period 4. This is of period 4. Together with calcium, 2882. That is said. So you have said that the period shows the number of energy levels shows the periods in which that element belongs. We have said that and have written it there. Then for lithium it will be 21. It is atomic number 3. 21. Simple 21. So it is of period 2. But now they are increasing from this part to this part. We said it is of increasing atomic number from sodium up to argon. Yes, so that is period. Now, what about the groups? What does the group signify? When we talk of group 1, group 2, all the way to group 0 or group 8. So you have hydrogen here. You want to see the relationship. And in this case, let us use this other part here. And I'll be writing those of period 2. Let's use period 2 and see that lithium has a configuration of 2, 1, beryllium 2, 2, boron is number 5, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. It ends at that point. And 2, 8. You want to see what does this group signify? Oh my god, signify. I am not sure of that word. Okay, we have 2, 1, 2, 2, 2, 3, all the way to 2, 8. And it can be seen that the number of electrons in the outermost energy level. When we talk of the outermost, we mean that the one which is iko mbali kabisa, outermost. This one. This is the outermost energy level. The number of electrons in the outermost energy level in each of these elements shows the group in which they are. So we have lithium has one outermost energy level and it is in group 1. Beryllium has two electrons in the outermost energy level. It is in group 2. Beryllium 3, group 3. Oxygen 6, it is of group 6. And neon is 8, it is of group 8, the outermost energy level. So given element X 286, you are asked in what period does it belong? We just said it is in period 1, 2, 3. What about in group? In what group does it belong? You can look at the outermost energy levels, and here it has 6 electrons in the outermost energy level, 6, and therefore it is of group 6. Yes, it is of group 6. Our element is sulfur. This one, 286. So we have seen that, and there's also another relationship I've written. So we have said groups shows the number of the number of outermost energy levels. The number of electrons in the outermost energy levels shows the group in which that element belongs. So this element X is of period 3. It is of group 6. Lithium 2, 1. Hydrogen 1. Sodium 281. Use black. 281. Potassium 2881. Like that. You can see that this alkali metals has a configuration of 1, a configuration of 2, 1, a configuration of 281, 2881. All of them have one electron in the outermost energy level. They have one electron in the outermost energy level. 1, 1, 1, 1. and they show the group in which they are. They are in group 1. Those of group 2, 2, 2, 2, 8, 2, 2, 8, 8, 2. They belong to group 2, and so on and so forth. So we cannot say what I'm trying to bring. The point is that we can check on their valences. Yeah, I want just to mention about the valences. And a valency is the number of electrons that an element or an atom of an element has to lose or gain in order for it to take part in a chemical reaction. What electrons does these elements have to lose or gain? In their case, they will be losing. They will be losing because it is easier to lose 1 electron than gain 7 to be stable here. So the number of electrons that they have to lose shows the valency. Hydrogen can lose 1 electron for it to be stable. Lithium can lose 1, the same case to sodium and potassium. And therefore, the valency of group 1 elements is they are of valency 1. They are of valency 1. Yes, valency 1. Yes. These ones are of valency 2, similar to their group. These ones are of valency 3. These are the group, they are of valency 4. They can either lose 4 or gain 4. These ones, you don't have valency 5. So we go to the other part of the nonmetals now, and now we start decreasing our numbers. We have said 1, 2, 3, 4. And it means if I say 3 here, both boron and aluminium has a valency of 4. When I go to group 5 now, I go downwards, it becomes 3 because now they can't lose 5. Instead of losing 5, they gain 3. This one will be of valency 2. So I went 1, 2, 3, 4, 3, 2, 1, 0. They rate it 0. So there's a relationship also in the periodic table that those of group 1 has a valency of 1. All those of group 2 have a valency of 2. Group 3 have valencies of 3, 4, 3, 2, 1, 0. So this part here is this is the middle. From here we have 1, 2, 3, 4 for groups. 1, 2, 3. Okay, is the middle we have 4 by 4. Okay, but at 2.4 they can either lose 4 or gain 4. These ones don't lose or gain. So we have 4, 3, 2, 1. 4, 3, 2, 1. Yes, it is at the middle. So with that now we have marked our elements on the periodic table. We have looked or we have learned on how we can draw or sketch a small grid and map our elements onto it. We have talked of the transitional metals. We have talked of what periods are and how they are named. We have talked of the groups 1 up to 8. We have named some of the groups: alkali metals, alkaline earth metals, halogens, noble gases, or inert gases. And you have seen the relationship between energy levels and periods. Also the relationship between the number of outermost electrons in each atom of an element, the relationship between that and the groups. So in the next part, we'll be checking on